from Mathematics Paper 1, 2025. So we have f of x is 2x plus 1 and g of x to be 3 over x minus 2. We want to find the inverse of f, that is f inverse of x. Okay, so it is very simple, right? We are going to, f is just the same as y, right? So we can write y to be equal to 2x plus 1. Okay, that is the first step. Then we want to make x the subject of the formula, right? So to do that, I can just subtract 1 both sides. So this will be y minus 1 is equal to 2x, right? Then the next thing, I can just divide throughout by 2. Everywhere divided by 2, then and write, x and x, 2 and 2 cancels. So this implies, x is equal to y minus 1 over 1, y minus 1 over 2. Okay, so that is the inverse, right? So where there is, because we interchanged x and, where there is y, you just put x, right? So this is just, f inverse of x is y minus 1 over 2. Okay, so let me just, not y, I need to write x here, sorry. X minus 1 over 2. So that is the inverse. Okay, so let me know in the comment section if that is clear. Okay, then the next problem we're going to, the same one. So let us just erase this and write b. So b, we're looking at g of, they write it like that, right? G of f of x. So when you see that symbol, right, this is just the same as g of f of x. Okay, so when they write g of f of x, it means in the function g, right, in the function g where there is x, you substitute the function f of x. Okay, is that clear? All right, so if that is clear, let us go ahead and do that, right? So remember, our g, I'll just write it here. Our g is given by 3 over x minus 2. Okay, so we said where there is g, where there is x in g, we put the function f of x, the whole function. So if I write g of f of x, it means this is 3 over, I don't have x in, I don't have x in the numerator, but here where there is x, I put this function, right? That is 2x plus 1, then there is minus 2 here. Okay, but remember, 1 minus 2 is just negative 1, right? So this is just the same as 3 over, 3 over 2x minus 1. Okay, so that is g of f of x. Okay, that's it, right? We are done, guys. So the next problem says, let us compute g of negative 2. So where there is x here in part C, right, we are computing negative 2. Okay, so we are finding g of f of negative 2. So again, what this implies is, where there is x, we put negative 2, right? So we can write g of f of negative 2 is equal to, what we found was 3, everybody over 2, where there is x, I put negative 2, then minus 1. Okay, so I can get rid of this. So what is this? This is just the same as, 3 over 2 multiplied by negative 2 is negative 4, minus 1 is negative 5. So this is negative outside, right? Negative 5. So g of f of negative 2 is just negative 5. Okay? All right, so let us pause there a little bit and look at something that we can easily write on the you know, on the board. Okay. Pause right there. So let me see in the comment section if you guys are following. All right, let us continue. So let us go ahead and erase this. So I erase that. So I'm just doing selected problems. So okay, so let us go ahead and do, you know, the first few problems from the paper. So we have, you know, so let's say, so find the value of 4 to the negative 2. I mean, 4 to the power 1 over 2 multiplied by 4. Okay, 4 power 1 over 2 multiplied by 4. Okay, so remember we have the same bases, so we can add the powers. So this is just the same as 4, then to the power 1 over 2 plus 1, right? Any number is to the power 1. Okay, so what is this? This is just the same as 4. So remember this one, I can write it as 2 over 2, right? 2 over 2, because I just want to make the denominators to be the same so that I can add the numerator. So 1 plus 2 is 3, then over 2. Okay, then I just need to remember that, you know, I can write 4 as 2 to the power 2. So inside I have 2 to the power 2, then everybody raised to the power 3 over 2. Okay, so you know what, 2 is just the same as 2 divided by 1, right? 2 divided by 1, so that, you know, the 2 in the denominator cancels with the 2 in that numerator. Okay, so you remain here with 2 to the power 3. But what is 2 to the power 3? 2 to the power 3 is the same as 2 multiplied by 2 multiplied by 2, 3 times, right? So 2 times 2 is 4, times 2 is 8. Okay, so our expression 4 to the power half multiplied by 4 is equal to 8. All right, you can pause and I erase, then we continue. All right, so what about this simplification? Actually, it's factorized. They're saying factorize. So we have factorize. Okay, so what are we doing? We are factorizing. So we are factorizing something very simple. 3a minus c minus 3ab, then plus bc. Okay, so it looks very simple, but it is a little bit tricky, right? Because you have to figure out something. So let's see. So I can decide to rewrite what I want to factorize, right? So for example, I can do 3a minus 3ab because I can factor out 3a. Okay, then in this next one, anyway, let me just write the way it is, minus c plus bc, and we will observe what will happen. So in the first one, let us go ahead and factor out 3a. So 3a outside, we need 1 here, right? We need 1 here so that we can have 3a, that is the product. Then minus, if I factor out 3a, I remain with b here. Okay, so remember, when you are doing this kind of factorization, whatever you factor out in the second sum, you need to have 1 minus b in the parentheses. So if that is the case, then let us see, we can factor out negative c here. So I factor out negative c. If I factor out negative c here, I will need 1 inside here so that when I multiply negative c multiplied by 1, I still get back my negative c. Okay, So if that is the case, then I will need a minus here, right? Because remember, this is a plus and you factored out a minus. So a negative number multiplied by a negative number should be positive. So I need a minus, then minus b. Okay, so as I said, you can see 1 minus b, 1 minus b, they are the same, right? And 1 minus b is common, so I can factor out 1 minus b. Then I remain with 3a minus c. Then that's it, right? And you are done, guys. You are done, guys. You are done, guys. Okay? All right, let us look at the next problem. Next problem, we are solving a quadratic expression or equation, which is a little bit tricky again because you have x minus 1 squared minus 25 is equal to 0. Okay, so the first thing I don't have to expand, x minus 1 squared, because this is already like in perfect square kind of problem. So I would just write, x minus 1 squared is equal to 25. So I just added 25 both sides. Okay, so if this is the case, then I can take the square root both sides, right? So if I do so, I have x minus 1 is equal to, if I take the square root of 25, I will need either a positive number or a negative 5, positive or negative 5, right? Because negative 5 squared is 25 and positive 5 squared is still 25. So that is why I have positive or minus 5. Now, this leads to two important equations. The first one is x minus 1 is equal to 5. Then the other one is x minus 1 is negative 5. Okay? And if that is the case, I just solve, right? So what is this? This is x is equal to, I can just add 1 both sides. So that 1 minus 1 is 0. And 1 plus 5 is 6. So x is 6. Or on the other side, I have negative 5 plus 1, which is negative 4. So here x is negative 4. Okay? So for that quadratic equation, x is either 6 or negative 4. Okay. So let us see. Let us do something with arithmetic progression. So I erase this one. So an arithmetic progression, I just write AP, right? An arithmetic progression has, 7, 11, 15, 19, okay? And we want to find the 10th term. So let us find 10th term. Okay. So for us to find the 10th term, we're going to use our simple formula. So this is just like term number 10 is equal to that is a plus 10, right? Plus 10, which is our n, then minus 1 multiplied by d. So d is the the common difference. Okay, so you can see that our first term is 7, and 11 minus 7 is 4. So our d is 4. So here we have a, which is 7, then plus 10 minus 1 is 9, and our common difference d is 4. So I have 7 plus 9 multiplied by 4, and this is just what? 7 plus This is just 36, right? 36, and 7 plus 36 is exactly 43. Okay, so the 10th term of this arithmetic progression given by 7, 11, 15, and 19 is 43. Okay, so let us find the sum of the first 12 terms, right? So sum first 12 terms. Okay, I just write in shortcut, right? So we're just going to use our formula. So S12 is given by S12 is that is just, you know, n over 2. Then here it will be like what, like 2a plus like n minus 1 multiplied by d. Okay, so let us go ahead and substitute. Actually, I was supposed to write like Sn, that is just for general n, right? Then this is S12 is just 12 over 2, then 2 multiplied by 7 plus, this is like 12th term, so 12 will be minus 1, then I multiply by d. We said 11 minus 7 is 4, 15 minus 11 is 4, so the common difference, we said it was 4. Okay, and if that is the case, then we can just simplify, right? So I will erase on top here. So outside, we have 6 divided by, so here, right? So S12 is 6 divided by, 12 divided by 6 is, 12 divided by 2 is 6, right? I'm saying the answer already, okay? Then inside, you have 7 by 2 is 14, then plus, so look at this side, this is just 12 minus 1 is 11, then 11 multiplied by 4 is like 44, so you have 44. Okay, then you can just go ahead and multiply. So 6 in parentheses, you have 14 plus 44, which is just 58. So this is just 58. Then we can multiply 6 by 58, which gives us 348. Okay, so the sum of the first 12 terms is 348. Okay, all right guys, so if that is the case, let us see this problem, right? So I erase this, so let us see this interesting problem. So you have been given a point, right? So I will not just show the picture here just to save time, but if you look at the paper itself, you have a point A, which is negative 13, comma 2, and another point B, which is just negative 10, comma negative 2. Okay, so the question is find the distance between A and B. Very simple, right? So what I'm going to do, we're going to use our method, right? Our formula. So our formula is distance is what? That is the square root of, this is x, for example, I'll just say x2 minus x1 squared plus y2 minus y1 outside squared. Okay, so you just plug in and simplify. So let us go ahead and do that. So if we choose our x2 to be, so let's this one be 1, this one be 2, right? Our second coordinate. So I just put our x2, which is negative 10 here, then minus x1 is 13, but 13 is negative, so this becomes positive, right? So I have negative 10 plus 13, then I square this, right? Then plus, so our y2 is negative 2, so negative 2 minus, now this minus will remain minus because 2 is positive in the first coordinate, right? So this is 2 here. Then I don't forget to square. Okay? So if you're following, look at this. This is just 13 minus 10, right? 13 minus 10. And that is just my beautiful 3, which I will square. Then plus. Here, negative 2 minus negative 2 will be negative 4. But I square, right? Which is very simple. Then we'll go ahead and, simplify, right? So 3 squared is just 9, right? 3 squared is just 9. So I erase here, right? So this is just, the square root of, 9 plus 16, which is just 25, okay? So here I find the square root of 25, which is just 5. So the distance between the coordinates A and B is 5. Okay. So again, I erase this one here. I erase that, and let me see another interesting problem here. I saw one problem from calculus here, question 19. So let us find the integral of 6x squared minus x plus 3 with respect to x. Okay? So this is very simple, right? If you see this kind of equation, so remember when they talk about integration is just the reverse of differentiation, right? So in a more general sense, if I give you x to the power n, the integral of that with respect to x is just same as what? X, then n you add 1, right? The exponent you add 1, then you divide by this new exponent, n plus 1. Okay? Then because this is an indefinite integral, meaning that there are no limits, you just add your integration of constant of integration, you see. Okay? So we use that. Let us go ahead and do that. So if we do that, you can see that this is just, 6. Then this is x. I will write 2 plus 3 plus 1, right? Yeah, I'll just write everything and then I just simplify. I know we can do this more faster. Then this is x. The exponent is 1, so I add plus 1. Divided by what? Divided by, let me just add 1 plus 1. Okay, now what about 3, right? So remember, 3 is 3, x to the power 0, right? Any number to the power 0 is 1. So 3x to the power 0, that is just to be plus 1. Okay? Then in the denominator, 0 plus 1. Okay? Then now we can do our simplification. So this is just, 3 divided by 6, which is 2. So we have 2, then x to the power 3, then minus. So here we have, x to the power 2 divided by 2, then plus, this is just 1, right? In the denominator is 1, but we have 3 outside. So 3x, then I just add my constant of integration, which is SC. Okay? So we're done, right? So the integral of 6x squared minus x plus 3 is 2x to the power 3 minus x squared over 2 plus 3x plus c. Okay, that's it, right? All right, guys. So let's do one more problem, then we can pause it here, right? And then the rest of the problems we can do them in the next session. So the last exciting problem is this simple problem, right? So the simple problem is, they're saying solve, right? So let us go ahead and solve. What are we solving? We're solving for x, right? Given that x to the power 3 is equal to 8. Okay? So you can see here that, This is a very simple problem because I can just introduce cube root, or if I want, I can write 8 as a base of some number to the power a number, right? And I know that this is just, x to the power 3 is equal to what? This is 2 to the power 3, okay? Because 8 is just 2 multiplied by 2 multiplied by 2 3 times. So you can see that, the exponents are the same, right? The exponents are the same, meaning that the bases should be the same, right? Because there is no way that the exponents are the same and the bases are different. So if that is the case, meaning that here, therefore my x is just 2. Okay? Very simple, right? My x is just 2. Okay? Alright guys, so let us do one last problem. I said this one was the last problem, but I see one interesting problem, which is about variation, right? So I erase this. Then the question says P, right, varies. So I just write in shortcut. So P varies as Q, right? P varies as Q. So I write Q here, okay? P varies as Q and inversely as the square of R. Ooh. So P varies as Q, so that is just direct variation. Then because of the inverse, right? And it also varies, as the inversely as the square. So inversely it will be divided by, R squared. Okay? So let me come again, right? If they say P varies as Q, that is just P varies as Q, like directly. But if they say P varies inversely, meaning that it is going to be 1 over R squared. Okay? So because this P varies directly as Q and inversely as R squared, that is why we have Q over R squared. Good job. So if that is the case, then we can just write this now in as an equation form. So this is P is equal to, immediately you introduce equal sign here, you have to introduce your constant or variation, which is K, then divided by R squared. Okay? So the next question, they're saying that, so that is the first step. Then they're saying if we use P, Q, R. So this is in the table, like P, Q, R in the table are given, which are just 9, then 12, and 2. Let us find the value of K. Okay? So you have 9, 12, and 2. Let us find the value of K. So guys, this is like very simple, right? Because I just plug in and simplify. Okay? So let me do that quickly here and simplify. So if this is PQR, meaning that P is 9, Q is 12, and R is 2. So where there is P, I put my 9 is equal to K. Where there is Q, I put my 12, and where there is R, I put my 2, which is squared. Okay? So if that is the case, then this is just what? This is just 12K divided by 4. Okay? I just simplified, right? 12K divided by 4. Then I can simplify further, right? Because 4 goes into 12 3 times. So I have 3K. Okay? I have 3K. So meaning that the whole problem introduces to 3K is equal to 9. Okay? Then this is more cheaper because I just divide throughout by 3. Throughout by 3, then 3 and 3 cancels. 3 into 9 is 3 times. Okay? So in that problem where P varies directly as Q and inversely as the square of R, the constant of variation is K is 3. Okay? So having the constant of variation, if they give you other values of maybe P and Q to find R, you just substitute. Where there is K, you put 3 and make R or Q or P the subject of formula, and then you can solve, right? Okay. Oh, yes. Actually, there is a problem like that, right? So let's see. Let me leave it this here. Right. I wanted to skip that one. Sorry, I didn't see it. So the the original expression is this one. So we said P is connected by KQ over R squared. The K is the constant of variation, so K here is 3. Okay. Then the question is find A, right? Or find A um, Q if Q is 42 and your R is 3. Okay, so we're looking for P. Actually, we're looking for P if that is what we are given. Okay, so from that table, the table they gave A, but we know that our A is the P that we're looking for. Then we said K is 3 and Q they have given us as 42 and R is 3, right? So 3 squared, which is just our 9, right? So let us go ahead and do the simplification. So 3 multiplied by 42, remember this is paper 1, so you're not using a calculator. It is just 126. Then everybody divided by 9, right? So 126 into 126 divided by 9 is 14. So the value of P in that case is just, is just 14. Okay. Yeah. So I think the other problem was find B if P and let me finish this problem, right? So let us see if if they give us P to be 6 and Q to be 72, what is R? Okay, so in this case we just substitute again, right? So P is 6, which I write 6 here. Then the constant of variation is 3 and Q is 72, right? Meaning that the R here, which is the B that we're looking for, I'll just write R squared actually. R squared that we're looking for, which is the value of B, of course, is that, right? So fast forward here, this is just 3 multiplied by 72 is 216, then divided by R squared. Okay, so if you do your multiplication here, this is just 6 R squared is 216. Then if you do your division here, R squared is 36, right? Is 36. Okay, and because this is a direct variation kind of problem, so here you need R to be 6. Okay, R cannot be a negative number in this kind of problem. Okay, so all right guys, so I end it here and I will see you in the next episode where I will finish these other remaining problem that I did not do in this live video.